Good day, I'm Soting, s47340. Today I would like to present my final year project which entitled Characterization and Theoretical Studies of the synthesized field-string chalcone derivatives as potential organic semiconducting materials. Here's the top layouts for today's presentation. Let's begin with the introduction. The main topic of interest about the chalcone derivatives can be contributed to their extraordinarily crystalline properties, and not forget to mention is their distinguished semiconducting characteristic which exhibited intrinsically. And the most causing issues of the inorganic raw materials is because they require extremely high cost of processing fees, and somehow they need some critical requirements to be satisfied in order to make sure that the whole manufacturing process going on very smoothly. And therefore the organic materials featuring the pi conjugated system have emerged as one of the most ideal candidates. The main objectives of this finding is to access the theoretical and as well as the experimental data with the use of the quantum computational method. Besides it to synthesize and characterize the targeted compounds using the selective spectroscopic and analytical approach. Finally, is to fabricate the thin films using a deep coating method. Has a list of the literature reviewed and the flowchart of the overall work. The outcome of the solubility test proved that both of the compounds are polar in nature. Let's move on to the key findings. And all of this theoretical computational results is derived from the density function theory (DFT), and as you can see, the global reactivity parameters, which is the energy band gap, suggests that both of the compounds are conductive. This is because their energy band gap are very low in value, typically below 3 electron volt. Has a CHN elemental analysis, and it can be summarized that both of the compounds are very pure because the theoretical and experimental sets of data, their percentage of error is very low, below 1%, and for each of the element in the molecule. The structural identifications for both of the compounds can be characterized via the NMR analysis. The infrared analysis pinpoint their vibrational bands for each of the vibrational frequencies of the functional group for the molecules itself. Here's a UV spectra of the experimental and theoretical data for the tighter compounds, in which both of them also somehow show some degree of beta-chromic shifts due to the strong intramolecular charge transfer. And here's the energy band gap. Even though there's some slight deviations of the theoretical data from the experimental data, but it is somehow still considered as very relevant because the theoretical computations was carried out under gaseous state. Here's the surface morphologies of both of the compounds, and it can be highlighted that LSTM1 is highly conductive as compared to LSTM2. This is because due to the presence of the intensive network of cross-linking of the microfibrils, and it is somehow assumed to facilitate the mobility of the charge carriers from one side of the molecule to the other side across the surface. The third nonlinear optical response have been measured by the Z-scan technique, and both of the profile of the compounds also show that they exhibit self-defocusing effect, which can be supported by the theoretical data, whereby the second hyperpolarizity magnitude is negative in value. It can be summarized that both of the compounds have been characterized and synthesized successfully. However, LSTM2 is highly nonlinear active as compared to LSTM1, as due to the bulkiness of the moieties itself. In the future, we expect to explore more different kind of modeling approach with optimal basic sets in order to increase the accuracy and precision of the data. Not forget to mention is to refine the deep coding technique with some kind of automated setup so that to form a more homogeneous and smooth surface, and as well as to avoid the formations of defects on the surface. Here's a list of references that I used, and especially thanks to the Malaysian Ministry of Education for the funding support, as well as my supervisor, Dr. Wan Muhammad Khairul, and my co-supervisor, Dr. Lee Anju. Thank you.